Get along with Papa? You do. You have no see.
Hope you're all struggling. Yeah, they look like questions I made up. Hopefully it comes out nicely. Got more questions to do than exam questions.
Mr. Chan, are we going to have a test on this chapter? Or
are we going to have what?
Are we going to have a test on this chapter?
Yep.
When is that?
Yeah, probably. Tomorrow's the double class one. Maybe Wednesday. Actually, do I? Yeah. Maybe Wednesday. Give you a bit of time to revise the skills. Hopefully this time, scores are better than chapter 1. Of course. Let's see. Most of us done? No? Let's go through the answers. Here we go, first one. Now you can use quotient rule if you wished. I probably would have went straight to power rule. So for each and every one of this, I normally simplify when I can. And this is the same thing as saying 2x squared take away a half. Just because you're dividing x squared by x to the power of half, you can subtract the powers. You can do the same for the next one. That'll be minus 4x to the power of 1 minus half. And then plus 3. Now, there is no x's, or you can think of it as x to the power of 0 minus half, which actually is the same thing as saying negative half. Okay? And then I just simplify that down. So this is still y. I haven't differentiated anything yet. I just change that to 2x, and what is that? 1.5, so it becomes 3.5, or 3 over 2. And then that's 4x to the power of negative half. And then plus 3x negative half. No, that's not negative half, that's half. I thought that was strange. All right, and then now I can differentiate, and that's much easier to differentiate. I can say dy dx equals 2, 3.5 times 2 makes it 3. And so that's 3x minus 1, which is half, minus 2x to the power of negative half, and then minus 3 on 2, x to the power of negative 3 on 2. Okay? And you can rewrite that as 3x root of x minus 2 on root x, and that's what? Minus 3, 2, yeah, I'll just do x. No, you don't. I'm just saying.
You can just stop at the dx.
Normally you won't get anything weird like that, so that you don't have to flip it around. It's just because I made up these questions, so it's likely that you get something weird like that. Normally just try to keep it all negative powers. Don't leave negative powers as possible.
Get rid of the negatives.
Yeah, get rid of negative powers. Okay, so that's my approach. Now obviously if you use quotient rule, then you would have had collected this together and it would have been a massive chunk. Regardless, it probably would be right if you followed the rule correctly. Next one, this is, I use chain rule for this one, so it's a double chain rule. Derive the inside, and derive the outside. Yeah? So if we do it slowly, I'm going to try to use colors so you can see what I'm doing. dy dx, we want to derive the inside, but the derivative of the inside requires to derive the inside again. So I'm going to do the very inside first. Okay, so it's a double chain rule. So pretend that I didn't give you the log, and I'm just saying find the derivative of sine of e to the power 3x. What you would have done was derive e to the power 3x. Okay? Now, if you derive the inside, I'm going to use colors here. Derive e to the power 3x. Anyone know what that is? 3e to the power of 3x, because the derivative of 3x is 3. Derivative of the outside, e to the power 3x is itself, so e to the power 3x. And then multiply that to the derivative of the outside times, now that's 2, derivative of sine is cosine of e to the power 3x. So notice I'm keeping that, that's the derivative of the inside. I've done a double chain rule there. Okay? Then I got to multiply that with the derivative of the outside, which I'm going to use another color. Times that with the derivative of the outside. Now derivative of the outside is derivative of a log. And derivative of log is 1 over whatever the inside is. And so that would be 1 over 2 sine e to the power 3x. Okay, so you see how I'm doing it all in one go, one step. And that is the expectation by end of year that you would be able to do all that. Okay, and so then you say, all right, let's multiply all that together, and that now gives you 3e to the power 3x, or times 2, that gives you 6e cos of e to the power 3x, all over 2 sine e to the power 3x. Okay, and conveniently 6 and 2, you can simplify that down to 3 and 1, so that becomes 3e 3x cosine of e 3x, whoops, all over sine e 3x. Okay. And obviously if you learnt from special, you can simplify the cosine over sine and rewrite it as cot of e to the power 3x. But for methods, leave it as it is. Okay. Now, I think the only confusing part is that double chain rule. Okay. Hands up if you got that double chain rule part here correct. Okay, a few of you. All right. That's something to practice. Okay. It is. Do I normally see an exam? No. Normally it's probably a linear equation here, but they do expect you to be able to do log of a sine of a cos of a tan. Okay. I just decided to put an exponential to make it a bit more complicated. All right. Sorry? Yes, you can, but for methods we don't deal with cot, so we just leave it as it is.
So I could have gave it as like 3 to the 3x on tan 3 tan e to the 3x.
Say it again?
So they did instead
3e 3x.
On tan.
Yeah, because tan of e to 3x is the same thing as saying sine e 3x over cosine of e 3x. So if you put that in the denominator, it's the same thing.
That's okay though.
Yeah, it's fine. Okay, so, and then the last one, I would use quotient rule. Okay, so quotient rule, if you've forgotten, it's VU, Victoria University first. Okay, VU dash minus UV dash divided by V squared. That is the derivative using the quotient rule. So if I called this U and I called this V, then I know U dash must equal to 1 on X and V dash equals to 2X. So if I just follow this concept, VU dash, so V was just X squared times U dash, so X squared times 1 on X, minus U, which is log E of X, multiplied to V dash, which is 2X, divided by V squared, so that becomes V x to the power of 4. Okay, and then you can simplify that, so X cancels out, and you get with X minus 2X log E of X, divided by X to the power of 4, but convenient, huh? Yep, you can simplify that again, cancel out or take out a common factor of X, and that means you can cancel out a factor of X on the denominator, so that now makes it X cubed 1 minus 2 log E of X. Now, was that hard? The only hard part, I'd reckon, would be here. Double chain rule. Okay, the double chain rule is like, we know you have to derive the inside, do a separate part to it, derive the inside of that too. And over time, you'll be able to do it the way I'm doing it. Okay, you can do it all in one line. But to start off with, just write it out. Take up the space. Doesn't matter. As you're learning, it's okay to take up the space. But over time, yes, this is the expectation that you have to be able to do. Differentiate. Chain rule, chain rule. Okay. Sometimes it's chain rule and product rule. And that becomes a bit more complicated. So for example, I could have had log E of x squared sine x. And that becomes a chain rule of a product rule. And that gets more confusing. Okay. All right, so that was a recap of what we had to do, and you can probably see a few once I give you one of these booklets. They're exam revision, they're all exam questions. You get an idea of what the derivative is like and how you find the gradient, tangent line, etc. Okay. Now today it's pretty straightforward. These are the actual solutions, so you can have a look at them later. Today's very simple concept because I already taught you what differentiability is, but just recap. What are the conditions for a point to be differentiable? What did you have to prove in exam? There's a few things that you had to show, and once you show that, then you can say it's differentiable or not. What are the conditions again? Remind me, Jack. What are my conditions?
Has to be continuous.
Has to be? It has to be continuous, yes. 1, it has to be continuous. What does continuous in sort of human language, what does that mean, David? You were moving your hand correctly. What does that mean? It's continued graph. If you can draw the graph without lifting your pen, it is continuous. Okay? So I want to write here without lifting pen. Okay, so that's one. What's the second condition? What do you need, Alice? Not sure. How do I know when it's not differentiable? And the classic example I always refer to is the modulus graph, that you have this, and why is it always not differentiable right at that point? What was the reasoning again? Gradients aren't the same. Okay, so how we say it is we write it as limit of x approach a number, in our case it's approaching 0, with the negative, so we write the negative just on the side here with the power. This means comes from the left. If the limit, so meaning if you approach the gradient, so f dash of x, from the left, if it equals to the approaching to the same point but from the right, so the positive means to the right, if the gradients are the same, that point exists or has a gradient at that point. And the classic example is this modulus graph, because we know this is x and that's negative x. Then the gradient is clearly 1 and negative 1. So if we were to sketch the derivative graph, or the derivative graph, so y dash and x, we can clearly see that it is gradient of 1 and gradient of negative 1. So when x is less than 0, gradient is negative 1. When x is greater than 0, gradient is 1. And clearly, right at x equals to 0, we don't know what the gradient is. It could either be negative 1 or 1, depending on where you're approaching. That's why it doesn't satisfy second condition. So that's differentiability. And so if you're doing an exam, it's one of these two that you have to state. Okay, that's testing whether you understood what it means to be differentiable. Okay, and today's session, why I said it was easy, because now you're just looking at what it means to be continuous, and then applying limits. So understanding how to use limits, which you guys already have done for differentiability and first principles. Continuity is the only other one. Okay, and I mean, in the most simple sort of way to understand it is if you can draw the graph without lifting your pen, you've satisfied the conditions for it to be continuous. Okay, but we're just going to look at the mathematical definition for it today. So limits, we know it's when it approaches, it's more of an estimate, like we're picturing what it would be if we were getting close. For example, the 1 on x function, we can never know what x equals 0 is, but we can see that as you approach towards x equals 0, it becomes infinite. So y values are getting very large, and so we approximate it to be a very, very large number. That's what the limit's for. Okay? It's just to help you approximate it to something. All right? Now, along with that idea, these are all the sort of rules or properties of limits which you already have applied just implicitly. That's all. Okay, and sometimes they come up in your multiple choice questions and you plug it in your calculator and you get your answer. Okay, so that's why it's not normally something that you have to worry about too much. It's just a simple concept of estimating what it will be. It's what you've been doing in your exercises. Okay, now let's move on to continuity. This is the definition. I want you to copy those two down. These are the only two mathematical definitions, and I'll explain what each of those mean, and logically, why do we just say if you can draw the graph without lifting your pen, it is continuous. This makes sense, okay? So it says here, a function f is continuous at the point x equals a if the following conditions are met. First one, f of x is defined at x equals a. The second one says limit of x approach a for f of x is equivalent to f of a. Okay? Now that sounds really mathematical or really hard to understand. If we think about it, I'll just draw it again here. What it's really saying is you've got a graph. You've got a graph. Doesn't matter what graph it is. Yeah? That's my graph. They're saying that for a particular point to be continuous, because remember this is made of infinite points. There are infinite points around this curve. There's 1, 2, 3, 4, and it goes infinitely, right? But for every point to connect with the next, which means it's continuous, it has to follow this concept. So what does it mean by the first condition? It says f of x is defined at x equals a. That just means if my function was root of x, for example, okay? It's just saying at x equals -1, for example, does it exist? Is there a coordinate? So if I sub -1 in, will I get a coordinate? Because if I get a coordinate, it exists. That's what it means by defined. So at x equals a, is there a y value? That's all it's asking. Okay, so for example, with this one, clearly at f of -1, it is undefined. Okay, so that already doesn't meet the first condition because there's no value for it. Okay, because there's no value right at that particular point, it can't continue to the next. So that's why there has to be a disjoint, or sort of there's no coordinates there. That's why when you draw a graph, if there's a disjoint, then you naturally lift up your pen and you continue, because that particular point does not have a value. Because when you draw a line, you're actually saying there's infinite y values, infinite coordinates. That's what you're really saying when you draw a line. Otherwise, they should just be dots, is what it should be. But when you draw a line, you're saying there's infinite dots in between it. That's why. Okay? So that's the first condition. They're just saying there has to be a y value. Second condition is like, all right, well, what if you do have a y value? It doesn't mean it's continuous, because you can have a graph like looks like this. I can draw this. So I can do this. And then maybe I'll do an open circle here. And then I say closed circle here. You can carry on. Okay? Is this continuous? Logically. Is it a continuous graph? No. Okay? It has values, yes, you have every single value, but it's not continuous. Because I can't draw that graph without lifting my pen. And so while we say that, okay, the first condition says that as long as you have a coordinate, if you sub in, yeah, if I sub in x equals a, there is a y value for it. This is f of a. So that's fine. But it doesn't mean that this is a continuous graph. That's why you need a second condition. So what's the second condition? The second condition says, if I approach this value from the left or from the right, okay, doesn't matter, left or right, you have to do both, then that value has to equal to the value that if you subbed it in. So if you subbed it in here, you said if you did f of a and it equals 1, okay, so let's say f of a is 1, so let's say this is 1 here. If that is 1, then it's just saying if I did the limit, approaching from the right, approaching from the left, if they're both equal to each other, well, they both have the same y value. But clearly in this example, if I approach from the left, you can see if I approach from the left, if I'm approaching from the left, clearly this number here is not approaching a y value of 1. So that's what this is saying. If I'm approaching from the left and I approach from the right, limit doesn't exist. Because I'm approaching from the right, it's approaching 1. The y value is 1, 1, 1, 1, 1, 1. Every coordinate here is 1, 1. The y values are always 1. But then if I approach from the left-hand side, the y values aren't 1. So therefore, the limit doesn't exist. If the limit doesn't exist, if there is no value that it actually tends to, and it's not exactly the same as 1, therefore it can't be continuous. So that's why you need two conditions. Okay, so you need the first one, meaning if you sub it in, does it exist? Yes, it does. Okay, so then if I approach from the left and approach from the right, do they both tend to the same answer? If it doesn't, it's not continuous. If it does, then it's good. So let's take a quick example of this idea. Let's say I do this. See, if this is my continuous graph, I drew that without lifting my pen. Let's test. If I chose this point, and this is my x equals a, what you can see is it will have a y value. So y value, let's say that's 3. So right here, y value is 3. If y value is 3, you can see if I approach from the left, the y value approaches 3. If I approach from the right, it still approaches 3. And so therefore the limit as I approach, limit as x approaches a of f of x, it equals 3. And then I test f of a, does it equal to 3? Yes, it does. I'm just hypothetically making up. Does equal to 3, therefore that point is continuous with previous and before. And then you test that for the next point, and the next point, and next point, and that's the definition for continuity. Okay? That's how you prove it. So if they ask you in a short answer question to prove it's continuous, those are the two things you got to show. You got to show that at that point it does exist, and you got to show that the limit as you approach from left to right, that actually that value does tend to be the same. Therefore, it's continuous. And if it's continuous, it's potential to be differentiable. Okay? That's the only thing. Because this is a continuous graph. Modulus is continuous, but it doesn't mean it's differentiable at all points. So you can be continuous, but it doesn't mean you're differentiable. But you can't be differentiable and not continuous. Does that make sense? Think about that. You can't be differentiable and be continuous, because to not be continuous. Because in order for you to be differentiable, it needed to be continuous and the gradients are the same. So if it's not continuous, it's not differentiable. But if you're continuous, it doesn't mean that it is differentiable. Yeah, I know, yeah. So write that down. I'm going to write it down just so you can hear. I'm saying, for it to be differentiable, we said it needed two things. What was the two things? We said it has to be continuous, and two, gradients have to be the same. Same. True? So that means the graph has to be continuous, and it could be this one as well, but it has to satisfy these two to be differentiable. So I'll say not differentiable, ND, for not differentiable at this point, but this is differentiable for every point. But then, what does it mean to be continuous? Continuous means you need two conditions. You needed one, that it has to have a value at x equals a. Then, y values are the same on both sides. Values are the same. Okay? Now what I'm saying is, just because it's continuous, because this is continuous, it doesn't mean this is differentiable. So, doesn't mean differentiability. As the example of the modulus graph. Whereas over here, if you're differentiable, you have to be continuous. That's all I'm saying. Because the first condition says it has to be continuous. So there is, what I'm saying is you can't have a discontinuous graph and say that it's differentiable. Okay, as soon as you're discontinuous, it is not differentiable. You can be continuous, but not be differentiable. Or you can be continuous and be differentiable. That's all I'm saying. Okay? If that all confuses you, just remember these conditions. Okay? Any questions on that? Because that's pretty much the concept for today's session. That's all you're really doing. Yeah? And then I'm going to give you your book, give you an exam booklet, and you can practice those questions. I'll write up the solutions, because I don't have them. I'll write it up, and then I'll post it up on Schoology. Okay? All right. Yes.
X approaches 1 plus the top right approaching from the right and approaching from the left.
New exercises, right?
New exercise.
Or is it just the same one?
That's L and M. I might have given you. What? It just feels so thick. Oh. More questions. Do these questions. It's a good summary. It's a good idea to see how you do it.
You didn't know? Oh, it means
Alright, that's 4 more.
Remember that. I'll show you. Literally. When I first got
Oh, it's the same thing. I was hitting my back, folding this in this position, bracing your back. It's like doing a deadlift and not lifting anything.
Is it stapled or is it just?
No, they're not stapled. Yeah, I should have done it downstairs. They fold and staple.
Can I get rid of it?
Yes, you may.
Yeah.
Bro, did she say she's on the floor? Did she say she's on the floor? Keep taking your books off. Hey, where's she going? She's doing the extension. Smart eye, that's why she gotta leave early. Yeah. You're doing Jeremy for you didn't do it last year, did you? You wanted to, did you? Does the old man hook you up? Does he teach you at home?
Yeah. He will. When the exam comes up.
He'd be fucking ass then. Who's your teacher?
So it's pretty cool.
Mr. Whitty, or what? Is the other one still around?
Yeah, we have it on Wednesday.
Oh, you have a shit. Yeah. What does he say? What does he say? We can't do anything else.
What can I give you that makes it hard? Let's do another derivative double chain rule. Huh. Let's do a double chain rule. Let's try.
It's okay. Let's push it.
For those who'd like a bit of a challenge, not a challenge, but something you might see in an exam, it's a chain rule with a product or a chain rule with quotient. See if you can go, if you want to have a go with these two. It'll look a bit messy, but it'll be, it looks simple, you see, but when you do it, it'll take a bit of time. Take your time. Give the answers at the end of the session. We can use a calculator to check the answers. Let's try this.
So is that a yes or no?
It's actually no. But yeah, relative compared to You guys should let mine go, yes.
I did A.
What?
I did not done A. Let's do B.
I told you.
Minus 15 plus 3, 18, divided by 2. The difference.
What is X in the end?
What?
What is X in the end?
It means the gradient between points x equals 1 and x equals 3. I didn't step.
So what's answer to question 2?
2?
Yeah.
As in
Can you tell me?
this one?
What's on the sheet?
On the sheet. I don't have a sheet.
So confirm it.
Give it to me. Show me. Question 2. For the function with the rule, x cubed minus 4x, the average rate of change with respect to x on the interval 1 to 3. This is y2 minus y1 on x2 minus x1. So when x equals 1, f of 1 equals to 1 minus 4, which is negative 3. When x equals 3, f of 3 equals to 27 minus 12. So 15, yes. So therefore, y2 minus y1, so let's say f3 minus f1 over 3 minus 1. So that's 15 minus negative 3 over 3 minus 1, which is 2. That's 15 plus 3, 18, 9. y2 minus y1, and x2 minus x1.
You just find 2 points.
I'm going to do the toenail of
Alright, here we go.
Yeah. Oh, no. X of 0 is 2. Find derivative of what equals the
There you go. Unless I made a mistake somewhere, but.
I just try it. Okay, no, it's
And then you
probably Carlos.
where is he? When's this due?
That's why I use different colors then. The red one is the one
He doesn't speak it.
It's alright, this is just for
Alrighty, we'll have a test on Wednesday. Tomorrow we'll move on to a new topic or revision. But we'll have a topic test on Wednesday. Practice these revision questions. I'll make
Finished? Killed it there. Come on, BJ.